Alright, well, welcome to my second workbench upstairs that I use as opposed to the one in the basement. This is going to be a video on a little project that I put together that took me about 2-3 weeks to build. This looks like an ammo can, which, because it is. I had an idea when it came to Allstar, was I wanted a fairly portable node that was rugged, could be brought outside, possibly get a little rain on it, be a little bit protected from the elements, and something that could kind of take a beating. So yeah, I have a lot of ammo cans around that I use for storage of ammunition for my other hobby. And this naturally came about from seeing how the ammo cans are constructed. So I'm going to go over what exactly I did in constructing essentially a Allstar Micro Node repeater using the Baofeng BF-888 radios, a mobile duplexer, and the Raspberry Pi as my controller. So anyway, this is the can. You see on the top, this antenna here is the UHF antenna. I used a standard SMA connector fed through the can. This is a Nagoya antenna. Fairly inexpensive. I think it was around $12. And this is its actual transmitting antenna. And this antenna right here is the Wi-Fi antenna. I had to source a reverse polarity SMA to get this to happen. Initially, I was using this USB Wi-Fi adapter, and I had put a USB feed through right there. It's actually gasketed on the other side along with the power switch. Hang on a minute, so I'll turn around. So let's open it up and see what we have. This isn't terribly difficult. It's not the cleanest thing. I'm going to refine the design. But I've had very, very good results with some of the theories from some of the antennas when you try to move it. So this is the inside of the micro node. Maybe a little hard to see some things, but hopefully the camera picks it up better than I can see it on the little tiny screen here. Essentially, these are the two radios, the BF-888s, the receive and the transmit radio right here. I have right angles on most of the BNC connectors so that I could route the cables correctly, and it gave them a little flex to move within the case. So the radio itself is fairly easy to modify. There's a couple of articles online on how to remove the LED from the top and feed a wire through and make the correct connections. I'll have those links in the description. Along with that, the Raspberry Pi is actually buried in the bottom here. It might be hard to see. You can actually see the audio fob blinking. And everything is Velcro. I didn't screw anything because I wanted to minimize the penetrations to the outside of the case. I have these two over here. Move them back in the frame. You know, the two antennas, and then the power switch, and then the USB feed through. I'm eventually going to epoxy those so they're weather tight once again. And the whole thing runs. This is a 4-cell lithium polymer pack from Multistar. They're around $50, and they are one of the most expensive LiPo packs I've seen, but they perform admirably well. This thing will run for 3 days non-stop, and that's transmitting most of the time. I have the radio. The radio's doing about about 2.5 watts out, and the transmit radio, that is, and I'm getting about 1.5 watts on the output through the duplexer. And of course this is a notch duplexer, so no protection, but it's a small local repeater. So oh, you can probably hear it going off right now, IDing with the red light that just came on. So it's using, of course, my modified fob. This is actually, let me reach my hand in here, I can disconnect this. Actually one of the first fobs that I modified. A little ugly, but since the rest of the inside of this is ugly, I figured this was a perfect fit. And it fits right in here. Let me get it back in. There we go. And I have these connectors here. These are DB25s that originally this fob was set up just like the DMK URI. So that's why I'm using DB25s. Future, I'm going to use a DB9. In fact, I'm going to use 2 DB9s, one for each radio, so I can just disconnect the radios individually in case you need to do anything to them instead of having them both into one connector. So, then of course, I have a fuse block. It's a little large and clunky to be in here. And I'm actually running the radios off of a USB power converter. It's 8 to 30 volts input, and it gives you 5 volts output. I modified took the battery pack apart in each radio, and I modified it so that I could run them off a USB by using 2 diodes in series to drop the voltage down enough from 5 volts. Dropping it down by 1.4 volts, so to feed too much voltage to the radio. And the radios don't draw very much. I think the radio's drawing about, on transmit, about 1.25 amps, if I remember correctly. Just the transmit radio. At idle, the receive radio when it's receiving, I think, draws 300 milliamps. Don't quote me on that. I don't remember. Of course, I should have written it down, but it's kind of hard the way it is right now together. I was more concerned about getting it together than taking readings at the moment. So this battery charges with an XT90 connector. That's how the power is connected, and that's how you would also charge it. To charge this battery, you need a charger meant for lithium polymers. I actually have it. Let me reach my arm over here. This guy I got off of Amazon for about $35, made by Sky RC. They'll charge just about any battery that you have. Oh, let me turn the radio down. They'll charge about just about any battery that you have. And it comes with a whole bunch of different adapters and connectors. It has banana plugs on the side. It'll source up to, I think it's 6 amps. I think it's 6 amps. Yeah, circuit power 60 watts. I know it can source up to 6 amps. Yeah, charge 0.1 to 6 amps on here. I don't know if you can see that or not. Yeah, it's going to focus on it. So, and it's also a balanced charger. You have your balance taps on the side. Does a great job, and it's inexpensive. Doesn't come with a power supply to plug it in the wall. It runs off of a 11 18 volt supply, but you can get those for $12, and it'll charge your lithium battery. One thing you got to remember: this lithium battery does not come with a protection circuit inside. The protection circuit is going to have to be external. And I purchased a protection circuit from a company called allbattery.com. They had a 4-cell, 10 amp protection circuit, which also will charge the battery as well on its own. It acts as its own charger. But it's short circuit protection, over voltage protection, over temperature protection. It has a temperature sensor. I have it wrapped in some electrical tape around the battery pack just because it's a raw circuit board. So there's nothing you can do to protect it inside here. That I should say, nothing I could do to protect it inside here at the moment, and that was kind of field expedient. Just wrapped it around the battery, and I also wrapped the temperature sensor inside the tape, so it's up against the battery to do its job for sensing if the battery's over temping. So that, it's fairly simple setup. The one thing I did originally, like I said, I put a USB feed through on the case to look up that dongle. But you know, when I had that dongle in there, I out the front here, and I'm not going to plug it in because I have it on right now. Where did I put it? Oh, stuck on the top. Is it would stick out. It would stick out from the front like this. And I knew one day that this was going to get broken off. And it's not as clean. What I wound up doing is I did that and I stuck a piece of Velcro to the top here. That's where I would keep it. But I went and I had handy this. Oh, phone's ringing. Hang on a minute. Shut that off. But I had handy a Wi-Fi dongle, USB dongle that had an external antenna connector. Actually, I bought it for my laptop. And I found a wire off of Amazon. It was about $8 that had the correct connections on it. This reverse polarity SMA in here, and another reverse polarity SMA here, so that I can keep everything internal. And sure enough, you know, it works like a charm. I can close the case and it looks a lot cleaner. I'm not that concerned about stuff being broken off. So I can then use this front port to charge things. So so you can kind of take this along with you, and since this is Allstar, the Wi-Fi portion of it is meant to connect to the internet so you can connect to other nodes. And usually if you're going to be somewhere out, say out in the wilderness, you know, on a camping trip or something, and you happen to have, or for search and rescue operations, kind of why a friend of mine by the name of Dave, N2KTO, kind of was the inspiration for this, because he's involved in search and rescue operations in the mountainous areas. Putting one of these on the top of a mountain in an area that doesn't have adequate radio communication coverage would work wonders. Especially if you take this off with the SMA connector, you can put a real antenna, like a Slim Jim antenna, something quick you could throw up that's got some better gain than this, up a tree. And 1 watt, you know, 1 watt, 2 watts on the top of a mountain, most people underestimate how powerful a watt of RF power is. To give you an example, most microwave hops use less than a watt, far less than a watt of power for high speed, you know, long range microwave hops. Of course, they're using dishes, parabolic dishes, most of the time that focus the energy and give you a you know, amount of gain anywhere from 19 dB up to 40, 50 dB gain, depending on the size of the dish and the frequency you're operating at. But most people underestimate the power of a watt. So I'm going to demonstrate it right now online. I have my little Baofeng. It's my it says Micro Node on it, and I key it up. There's the standard, you know, courtesy tone, and if I do say a star,
Good evening.
star 81.
The time is 8:47 p.m.
Well, is it really 8:47? Yeah, I guess it is. It's getting network time from my Wi-Fi at the house. So let's connect to a node. I'm going to connect to my buddy Dave's node in New Jersey. So that's a star 7340813.
Node 40813 connected to node 43120.
And there we are. I'm connected to my buddy Dave's node, and you know, using a lot of power. And I can disconnect from it just by going there we are. That's a fully functioning node and an ammo can. And I'm going to try to post the parts list in the comments. Hopefully I can get it as comprehensive as possible. And if anyone would like to put one of these together, or if anyone has some ideas for me, I would be most appreciative. I've seen some other people make some portable nodes and stuff. Haven't seen one in an ammo can, at least not an Allstar one in an ammo can. So, oh, before I end this video, these are the commands that I use, and I specifically have a command. This for IP address of node. This is the local IP address. And just in case you need to SSH into the node, the way I do this is I use my phone. I set it up as a hotspot, and the phone it'll connect to the phone, and you'll see it. Your phone normally tells you what IP address it handed to the device it connected to. I know mine does, and I then connect my laptop to the phone as well, and use the phone as a little wireless router, and I then use that IP address to SSH into the node and make any changes. You know, in a pinch, inside, I mean, there's still the I don't know if you can see it down there, the connector, the RJ45 connector for the Ethernet service. You set up a fixed address on there, which I do have, just in case all else fails, and you can't communicate with the node anymore. With the Raspberry Pi. So to shut the node down, I have a shutdown node using star86. I have that defined in the rpt.com file. So I just go star86.
The system is going down for halt in 10 seconds.
And then it'll halt. It's IDing. It might even stop in the middle of IDing. And that's it. I usually wait about a minute just to make sure the Raspberry Pi is completely shut down. And once it's completely shut down, wait a little while, then I turn the power switch off. That's it. It's fairly simple. It didn't take a whole lot of hardware or tools. I mean, the hardest part was finding some of the bits and pieces. I'd say 95% of the stuff in this can is sourced from Amazon. The radios are, the battery is, the Raspberry Pi and the case are. I used a metallic case for the Pi. The Wi-Fi dongle is, so is the fuse block, which is just standard ATC fuses in there. Like I said, it's a little large and chunky, but it was inexpensive, and I figured it would do the job. It's really a nice little system. I do some traveling for work, and I kind of wanted something to drag with me into the hotel room, and have fun with. So the one thing you have to watch out when you put radios in a box like this and try to use them as a repeater is descents. These are literally $12 a piece radios, and I was worried about them desensing one another inside the same box transmitting. With the transmitter being so close to the receiver. And I do get a very tiny amount of descents, very very minute amount of descents when I have the antenna on the top of it. When I take the antenna off and I connect it to an external antenna system, I don't really see any descents at all, which is very surprising. I mean, I'm not running a lot of power. This is good quality cable. Cable I'm using here is all RG316. It's very good quality. The center conductor is stranded so that it's more pliable, more flexible, as opposed to a solid center conductor, which from flexing can break and kink, and I don't want to have that happen. But originally I tried to do this with RG58 or I forgot what what, the LMR 195 actually, which is equivalent to RG58, and it was too stiff, too big. You know, you would think RG58, geez, that's thin spaghetti stuff. But when you have such a cramped space like this, you can't do it. You know, you can't keep flexing that cable and trying to bend it around, and it was beginning to pinch. You know, it was going over the bend radius that's rated for the cable. I've had a lot of fun building this, so once again, any questions, comments, you can email me. Oh, good. In other news, my repeater that I have a UHF machine on 449.875 in Wind Gap, Pennsylvania, has just been placed online. Finally got an internet connection up to the site that it resides at. The node is 42816. So if you're on the Allstar network, more than happy to connect to node 42816 and have a chat. You know, I'm around. Some of the day when I'm at work. You know, depending on what I'm doing, and of course after work I get home 5-6 o'clock, and I'd be more than happy to talk to you. You know, there's a lot of people on here that are a lot more knowledgeable than me on Allstar. I'd like to say I'm pretty proficient, and I'm still learning the ins and outs of certain of the cooler functions of it. So I would be more than happy to talk to anybody. That's what ham radio is about. You know, experimentation and the public service. Public service is a big one. I mean, I think in that hobby, a lot of people, in the ham radio hobby, a lot of people have lost sight of the public service aspect of it. And this kind of resurrects it a little for me, because this is something, like I said, could be used as a search and rescue tool for radio communications. And I'm not saying it's the end-all be-all, I'm not saying it's the best thing out there, but for what it costs to build and how versatile it actually is, I would say it's pretty good. You know, once again, I would like to know, you know, if anybody's got any better ideas. I'm planning on building another one of these that's more refined and possibly has some more bells and whistles to it. I may add some more stuff to this too. The one thing that I think this lacks is indicators. You know, just a simple LED to show that the unit's powered on, just in case the switch gets flipped. One thing I do have, I don't know if I have it up here or not, is a little small LED display that shows the power out, that shows the voltage. One word of note is I tried initially to use the battery eliminators for the BF-888s. This is one of them I tried to use. I was going to connect them directly to 12 volts. You know, they're supposed to. They come with an automotive power connection on the end. In fact, here it is. The one I cut off. And the power that is produced by this is very dirty. I noticed a lot of grunge on the output of my transmit of the transmit radio, and I didn't know why. I thought maybe the radio was defective. And normally one of the first things I go to when I have a problem with just about anything is power. Is check the power. Make sure you have the proper voltage. Make sure that it's properly rectified and filtered. So I took the battery off I took just the battery that comes with the radio and I put it on the radio, and I tried the radio and it worked. It was clean. The output was clean. I checked it with the spectrum analyzer. When I went to using this, it was very, very dirty. That's why I went to that 5 volt, 8 to 30 volt in, 5 volt out converter made by Drok, D-R-O-K. It's a nice little device, works well, sources 3 amps. So the other unit that I used kind of in the planning phases, and I'll show this, and I might even be able to show the operation. Hang on. Let me get something here. We have It's a small USB voltage and current meter. It's inexpensive. It was $11. Took a while to get. Came on the slow boat from China. So let's plug that in. And I might have to have a load in it for it to work. Doesn't seem to want to work on that. I know my Wi-Fi dongle works on it. Alright. Unscripted. Let's do some troubleshooting. It is... Oh no, it's on. You know what? I know why. I shut it down. The Pi's off. Here. I gotta turn the power switch off. Power switch back on. And once the Pi boots, oh, there she goes. There she goes. Let's see if we can see that. Let's get a little zoom in there. Move it out. So it's giving me 4.97 volts. I don't know why this thing's not focusing very well. Oh, there she goes. That's helpful too. It'll read the IP address when it boots. So anyway, I connect the device to it. Here's my phone. Right now it's reading the voltage at 4.64 volts, and now it's reading the current at 0.39 amps, so 390 milliamps. That's how I... Oh, let me turn her down. She's getting annoying now. I use this to determine the current of the Raspberry Pi, and also of the radios and so on. And it's very accurate. I double checked it with my Fluke. I have an old Fluke 77 over here. But it does work. And you can use this to charge a phone, keep a phone powered while it's running as a hotspot. So it's a strange little device. It's like two circuit boards stuck together. Let's see if this thing will focus. Focus. Doesn't want to focus. Not sure why. Well, I'm not going to focus on it. So anyway, that's it. Let me know what you think, and hopefully I have another video soon.